Assalamu alaikum everyone, welcome to the video. In this video we will start by gathering some required background information before we start in understanding in brief different topics about programming language 1 course. So let us get started. In this slide we will see 5 topics, which are memories, data types, operators, syntax and semantics, and different programming languages, among which in today's class we will discuss only memories and data types. So first up, memories. Here there are some naming features which are basically theoretical questions. So if we look at them very line to line, the smallest unit of a memory in computer is a bit, which is also known as a binary digit. I believe all of you have already some basic knowledge, got some basic knowledge regarding binary numbers. Binary numbers are a number system that uses only zeros and one. 0 and 1 is the only digits that are used, and a computer uses only zeros and one, because just as I mentioned before, the smallest unit of memory is a computer in byte, and computer only uses binary digits. So when we say something that how the computer relays information or works with information, they only work with 0 and 1. Here's another thing. This slide is all about theory. There's nothing much to understand in it. That what it says, that collection of 8 bits is called a byte. We just name it. We say that when 8 bits are together, we call it a byte. Bit is usually expressed using a small b, and byte is expressed as using the capital B. Nowadays many of you actually use different internet tools to see the internet speed, where we see mbps. When you see that the mbps is shown in small b, it actually means megabits per second. And when you see capital B, which is not much seen in Bangladesh servers, because Bangladesh mostly used the small b, but if you ever see the capital B, you will understand that it's actually megabyte per second, mbps in that case. And in such situations you have to multiply it using 8 to get the speed in bits per second, because collection of 8 bits is called a byte. There's another very important concept when it comes to the memory, is called a word. In computer science, this is a very important topic, and it largely depends on the computer's architecture or processor. But as we are still in very primitive state and this course is in a very beginner stage, we will not discuss much about this word. When you are senior enough, when you go to senior courses such as computer architecture or such as, I think, microprocessor, then you will actually need to understand the concept of word. But for now, word is not important for us. We will just discuss with bits and bytes, that's all. Okay, here we see a table where as mentioned before, a bit only consists of 0 and 1. So I have given here 3 bits, bit 0, bit 1, bit 2. That means I am giving 3 bits. Okay, so using 3 bits, what I am trying to express in this table, I think you probably may have a little understanding about this if you have studied Boolean algebra, but still I'll go through it. That when there are 3 zeros, I will say that the represented number is 0. When there is 0, 0, 1, the represented number is 1, and hence I have given a table that represents numbers from 0 to 7 using 3 binary digits. So what is like this? For example, when you suppose sit for an exam, but or when you guys come to us with regarding a query or regarding some problems, what we teachers ask is, what is your student code? We only ask, what is your student code? So then you give us your code, then we do some kind of processing, then we say that okay, your problem is this, or we say, are you this, we say your name. So this type of features are called mapping. And over here what you're seeing, this is mapping as well. I'm saying when there is 0, 0, 0, it will map to the number 0. When it is 0, 1, 1, it will map to the number 3. And actually using this kind of system, this mapping type of system, computers, though are completely using binary numbers or binary systems, they can actually access other number systems, other languages. For example, we use keyboards, or we see in the screen English letters, Bengali letters and other letters, but computers only work in binary. They use this kind of transition tables to first convert our input into a binary number, and then when they complete the process, they use this binary, they once again convert those binary results back to back to a system that is readable to us, and thus we start understanding that what is the result, and this is how it is used. Now here's something, this is also a little theoretical concept, but there is some part of understanding. First up is, if we express a number using 3 bits, the maximum possible value will be 2 to the power 3 minus 1, which is 7. Okay, now to understand that, we will once again visit the previous table. If you look at this table very carefully, or you can pause the video as well and see that using 3 bits, what are bits? Zeros or ones. There is only 8 possible combinations. Only 8 possible combinations. You cannot create more than, you can try beyond these 8 combinations. You can only obviously try to make another combination, but you will never be able to make a combination, because I have already enlisted all possible combinations of zeros and ones in 3 subsequent sequence. So this is all that is possible. Now if we use this representation system and start numbering from 0, we can only express till 7. Now how many bits did we use? We use 3 bits, and using this information, this is what I have seen, that the maximum possible value will be 2 to the power 3, which is 8, minus 1, which is 7. Now why is this minus 1 coming? If we once again look at the table, we can see that the maximum number is 7, and the minus 1 is mainly because of this number, the 0. 0 is also being represented, and we do need to represent it, and hence because we are representing 0, we are having this 2 to the power 3 minus 1. Okay, now we have seen what happens if we use 3 bits. What will happen if we use 8 bits? We will get 2 to the power 8 minus 1, which is 127. I'm not expressing it because that will be a very huge table. 127 numbers, the tables will be huge. I only showed this, that's why I only showed the 7-digit tables. There will be 127 numbers that can be presented if we use 8 bits. Okay, if we express a number using 2 bytes, what are 2 bytes? Each byte means 8 bit, so 2 bytes means 16 bits, so it will be 2 to the power 16 minus 1, which is 65,536. And so far we are only talking about whole numbers known as integers. We will talk about integers. What am I trying to say? That when we do mathematics, we use numbers using decimal points. For example, 23.86 point, there is a point, but right now I am only speaking about whole numbers. Okay, and sign bits also need consideration. What is a sign bit? A sign bit means the number is positive or negative. That is when we use suppose 7. Okay, let's talk about 7. We can also say minus 7, but if we look at this table already, there is no space for another bit because I'm expressing using 3 bits. So when we have to consider sign as well, we need another bit, and we can make such as, if it is 0 then the number is positive, it is 1 then the number is negative, something like that. So for sign we need another bit, and this is what said over here, that sign bits also need consideration. Now why we need to know this? I mean, we are studying computer science, we will start coding, we will do coding. Why am I wasting so much time in understanding memories? Because at the end of the day, when we run a code, it actually runs on the computer, and a computer is basically all about what it has stored. We will be using the, I don't know, hard disk or SSD, we will be using the RAM, and all of these stuffs are actually memory. We need memory. So if you just learn coding and that's all, this is what the situation you will be on. You know how to fix stuff, but you don't know how to fix it. You know, this is like in my example, like you are a technician, you are given an engine or so, you can say that yeah, this is, I can fix it easily, but I don't have the tools. Because when you want to access or when you want to fix it, you will need to understand how memories work. Major problems of codings actually come from lack of using memories, lack of using pointers, lack of understanding of these concepts. Hence, you do need to develop your skills in understanding how memories work. However, this is all I will be providing for this course when it comes to memories. I will not dive too much deep in understanding the memories topics as well. For memories, we usually use bytes or words as mentioned before, and you can consider them to be a stack of similar Legos, each having its own color. Well, why are we talking about colors and stuffs? It's quite hard to express it right now. Before that, we do need to understand data types. So let's move on to our next topic, which are data types. Okay, remember the example of Legos. I hope you all understand what is a Lego. So see that Legos can be of different shapes. Okay, we see Legos with width 2 and length 3. We can see 2 by 2 and such. It can be of different shapes. They can be stacked up to each other. Each Lego piece can be stacked up of each other. So these types, when we say memories, can also be of different capacities. That is, memories can be of 1 byte, 2 byte, 4 byte, and so much and so forth. So we can say that different shapes represent different data types, that is different amount of memory that is being reserved for it, and different shape plus color can be different identifiers. Well, this is another important topic that will be discussed later, identifiers. For now you can delete it, but remember this type, that different shapes means different data types. For now, let us only consider the primary data types. We will also consider data type modifiers, and depending on the architecture of the processor you are using, the numbers I'm going to provide right now will vary, because once again, it's an architecture based system. So what I am going to provide is not a strict measurement, but an approximated measurement, or you can say a relative measurement of how each data type is larger or smaller than the other one. So here we are, different types of data. So first of all, we have the data type int, which represents the integer. It format specifier is a topic that we will be using later. It is used for expressing the data type when it comes to input and output. We will discuss or work with it later. And usually integers are represented using 4 bytes. 4 bytes, when used, we already discussed about it. 4 bytes means 4 into 8, that is 32 bits. But we do need to express a sign. Hence, we have to delete 1 bit. We are left with 31 bits. So it will start from -2 to the power 31, and it will go till 2 to the power 31 minus 1. This minus 1 is because of the 0 in the middle. So these are integer. Now, if we add unsigned, this word, before an integer, what will happen? Well, first of all, the format specifier will be changed into this percentage u. But look at this, the allocated size remains unchanged. It remains at 4 bytes. But if we look at the value, now it is once again 2 to the power 32, because we do not have the sign bit anymore. Now we have 2 to the power 32, and this minus 1 is because of the 0 that needs to be expressed, and we will start from 0. There is no need, there is no possibilities of having any negative numbers, because we declared that the number will be unsigned. Another type modifier for integer will be short, and when we use it, we will use this format specifier %d. What it does, it shrinks the allocated size, which will be reduced to 2 bytes. Now what will happen if we use 2 bytes? Well, 8 into 2 is 16, and we will have 1 bit dedicated to the sign. So we will start with -2 to the power 15 to 2 to the power 15 minus 1. Now let's combine unsigned and short together. What will happen? 2 bytes will remain, but as it's unsigned, we do not have a signed bit, so we will have 0 to 2 to the power 16 minus 1. So far we have seen type modifiers that actually shorten the allocation size, but what if we need to increase it? We use the type modifier long. What the long does is it increases, just like short reduces by 2, the long increases the allocated size by 2 bytes, by 2 times of the byte. So here we can see that we will get 64, 8 into 8, 64, and hence we can see 63 as the power over here. And we can add double long, that is long, then it will obviously go for 16 bytes. When we use unsigned long, it will once again lapse back to 8 bytes, just like long, but this time there will not be any negative numbers. Now pause it, take your time, understand these numbers, because this concept is important. Now if I say that a computer does not use 4 bytes for integer but it uses 8 bytes for integer, the unsigned short and long, they will change accordingly. That's what I said in the previous slide, that it depends on that instead of this. So take your time, pause the video, and let's get back to it when you're ready. Okay, so integers are not the only data types. As I mentioned earlier that we were only talking about whole numbers, we usually do need to work with other number types as well. For example, we use float or double. These are actually used for expressing floating point numbers. As you can see, there are points over here, so we work with them. As for long, the long, it can be added to double and we get a long double, so here still working. Character type data, for example the alphabets A, B, C, D, E, F, they are called character type data, or they are expressed as star, and we use %C to express them. They use only 1 byte, and this feature will be discussed in later in brief using ASCII tables. And there is another data type called void. What does it say? It says there are no values. Void means empty, and that is all. Character type data, the special data for non-numeric characters. Non-numeric means it's not the numbers. It is essentially a number, but it identifies as a character. For now, ASCII table is needed. So what is an ASCII table? If I try to express it, I can say that, let's see. Okay, so ASCII tables are tables like this. Okay, if you look at it carefully, there's some decimal numbers in the left column, and there, let's ignore the hex for now, and there are some characters in the right column. So okay, let's look at this one. Over here we can see the characters capital A, B, C, D, E, F, and in the left column we can see some numbers, some integer numbers. This is what an ASCII table is. Remember that I only just showed you a table of numbers. This is actually what is used in computers. This is called the ASCII table, and over here you can see if we get the number 67, it actually means the character C. Well, actually the computers does not provide us with 67. It gives us a binary number of the 67, and then we can say that the 67 actually means the capital C, and thus this is the ASCII table. You don't need to completely memorize ASCII table. You just need to memorize this part, that 48 is 0 and 65 is capital A and 97 is small a. If you memorize these 3 parts, you can access 0 to 9, capital A to capital Z, small a to small z, and this is all that is required for you for now. You do not need to know more than that for now. You just need to memorize these 3 numbers, and if you memorize these 3 numbers, you can easily access all the digits, which are this part. You can access all the capital letters of the English alphabet, and you can access all the small alphabets of the English alphabet. That is all which is required for now. and this is the ASCII table, which is accessible in the internet all through. So this is what is written. ASCII actually stands for American Standard Code for Information Interchange, and identifies 180 characters using numbers 0 to 127. The important to memorize, I have written this as well, that which ASCII numbers you have to memorize, but ASCII only uses 127, which is not enough nowadays. So we have larger tables, Unicode or other systems. But what Unicode does is Unicode keeps the first 128 characters from ASCII, so it remained unchanged. And still, as we are in a very premature state, we are still in a beginning state, we will study ASCII tables, or we will study using ASCII only. But Unicodes use more bits and can represent more characters. So that is it for today's class, and we will start from operators in the next class. Thank you everyone.